In this video, we're going to be doing more work with fractions, and this we're going to be dealing with is all the other videos with the order of operations, that is PEMDAS. Everybody's familiar with them, and let's go ahead and take a look at some examples of what we're talking about here. First, let's take a look at comparing fractions. So what I want to ask you is this. Which of the two fractions that I'm going to write is bigger? 1/4 or 1/6? Now I can make a more difficult example than this, but I want to make it simple. Which of these two is bigger? You may not know off the top of your head that 1/4 is the bigger number of the two. 1/4 is bigger. How would you know it for sure if you can't tell just by looking at it? Well, what we could do is this. Notice that the LCD is equal to 12. So I can write the 1/4 as 3/12, and I can write the 1/6 as 2/12. Now it's clear to me which one's bigger. 3 out of 12 is bigger than 2 out of 12. So the 3 out of 12 is the greater number. Similarly, that was no different than 1/4, so we now know that 1/4 is greater than 1/6. So we can tell which fraction is bigger if we go through the effort of getting a common denominator. Then it's really simple. Let's do a few examples. So this one is, let's fill in the blank. Let's say I'd like to fill in the blank with either a less than sign or a greater than sign. So I'm going to give you a bunch of fractions to compare, and you tell me which one's bigger and which one's smaller. So for part A, this will have several parts. We'll start with 7/8. I'll put my blank spot versus 5/6. Now as it stands, it's difficult for me to see which one is the bigger number. However, let me get a common denominator. Here, the LCD between 8 and 6 is 24. So what I'll do is rewrite the 7/8 as 21/24. So in order to make that happen, 8 times 3 was 24. So 7 times 3 is 21. I'll do the same with 5/6. 6 times 4 is 24. 6 times 5, I'm sorry, I said that wrong. 6 times 4 is 24. 5 times 4 is 20. So I can see that the 21/24 is greater than 20/24. And since these are the same fractions as I had before, I know that a greater than symbol goes into the first blank. Let's try another one. How about 1 versus 2/3? It should be pretty clear that 1 is bigger than the 2/3. However, just to prove my point, if I write 3/3 instead of 1, that is, they have the same denominator, it's easy to tell that 3/3 is bigger than 2/3, and therefore 1 is bigger than 2/3. Next, 53/7 versus 8. And once again, I'm going to go and get both of these to where they have the same denominator. So if you remember, this 8 is the same as 8/1. So in order to make an 8/1 into something over 7, I had to multiply by 7. 8 times 7 is 56. And here we see that 53 over 7 is less than 56 over 7. So a less than symbol goes there. Now let's complicate things a little bit. Let's do 13 over 9 versus 11 over 7. Let's see which one's bigger. Here, the LCD is going to be 9 times 7, which is 63. So I'm going to rewrite both of these fractions over 63. Let's start with the first one. I had to multiply 9 by 7 to make this 63. Well, 7 times 13 is 91. Similarly, I had to multiply 7 by 9. Well, 9 times 11 is 99. And so I can see that 99 is bigger than 91, so a less than symbol goes here. Now an additional complication comes in if I do the following. Now this is different. Whenever you deal with a negative number, let me go and put the negatives in. 91, it's the same numbers as before. While it is true that 91 over 63 is less than 99 over 63, when you're dealing with negative numbers, the order is the opposite way. For example, negative 2 is less than negative 1. Negative 5 is less than negative 3, for example. Negative 8 is greater than negative 10. So the bigger the negative number, the smaller it is in some sense. The reason why is because the more negative it is, the more to the left of 0 it is on a number line. So the farther to the left are the smaller numbers. So before, where I had 99 was bigger than 91, it happens that negative 99 is less than negative 91. So in this instance, you have to change the inequality to the other direction because of the negatives. They flipped it. That adds a complication you probably were not ready for. Let's do another one. Negative 3 4/5 versus negative 3 11 over 12. So what I'm going to do is change these mixed numbers to fractions. It's easier to work with them that way. And so remember what I do. Forget about the negative while you're doing this. 3 times 5 is 15, plus 4 more is 19. So I'll have 19 over 5. On the other one, 3 times 12 is 36, plus 11 more, that's 47 over 12. And they're negative. Now, since they have different denominators, I would like to get a least common one. Now, between 5 and 12, they have no common factors. So, the least common denominator between 5 and 12 is 60. That is, it's 5 times 12. So I'm going to rewrite these over 60. And let me put my negatives here and my negative here. Okay, 5 times 12 is 60. 12 times 19 is, let's see if I can get this right, 38 plus 190, that's 228. I'll leave it to you to figure that out. Then I did 12 times 5 gives me this 60 down here. 5 times 47 is 235. So now I'm able to compare these things. Notice that 235 is greater than 228. However, since they're negative, that switches the direction of the inequality, and so the inequality should be pointing towards the right. And then one last one. It's just I have to do it. Since 1/4 is a positive number, there's no reason to do anything over here. Although if you wanted to, I suppose you could write the 0 as 0 over 4, but there's no need. A positive number is always greater than 0. So the thing here is when we get the denominators to be the same, it's easy to compare them. And this is kind of what we were talking about before. So that takes care of the order part of what we're talking about, how to order them. That means from smallest to largest, which one's bigger and which one's smaller. That's what I mean when we talk about ordering them. Now, a second topic in here involves fractions with exponents. So, for example, if I write 2/3 to the 5th power, that means I take 2/3 times 2/3 times 2/3 times 2/3 times 2/3. You see a total of 5 of them there. And then when I multiply this, I multiply the numerators across. So notice that there are 5 2's there. So I could write the top as 2 to the 5th. And the same with the denominator, I could write that as 3 to the 5th. So in particular, you can see that this 5 as an exponent went to both the 2 and the 3. And what I end up with then is 2 to the 5th power is 32. 3 to the 5th power is 81. No, it's not. It's not 81. It's 243. Let's do -8 over 11 to the 3rd power. It's not a bad idea when you're dealing with negative numbers to put them in parentheses so that you don't forget about them. Let's first handle the negative. I have, when I go across here, a negative times a negative is positive, but a positive times a negative is negative. So I can ignore the rest and just put one negative down for these 3. Then I have 3 8s, so 8 to the 3rd over 11 to the 3rd. So this is -8 to the 3rd is 512. 11 to the 3rd is 1,331. And then let's do one more of these. -12 fifths to the 2nd power is -12 fifths times -12 fifths. This time the two negatives cancel, and it's going to be a positive answer. So I'll get 12 to the 2nd over 5 to the 2nd. And that'll be 144 over 25. Now, with all this said and done, we're ready to deal with the order of operations. This, of course, you know as PEMDAS. PEMDAS will be in effect for all the rest of the math that you ever do in your life. Let's do some examples to illustrate, to work some of these, to illustrate some of the PEMDAS properties. Let's start off with 1/6 to the 2nd power times -3/10 to the 2nd power. Now, according to PEMDAS, I should do the parentheses first, but in the parentheses there's nothing to do. It's just a placeholder for the negative sign, or for the 1/6 in the first instance. So the parentheses, there's nothing to do in there. I'll move on to the next one, which is the exponents. I'll do the exponents first, and then I'll multiply. So let me bring down my dot for the multiplication. 1/6, if I take this 1/6 times 1/6, or if I do 1 to the 2nd, 6 to the 2nd, I'll get 1 over 36. Similarly, negative 3/10 times negative 3/10. The negatives will cancel, but if I take 3 times 3, I'll get 9. 10 times 10 will give me 100. And then, as we typically do, simplify as you need. And I see the only thing I see that I can simplify is that 9 goes into 36 4 times. And so I'm left with 1 over 400. Next, let's try 13 over 6 minus 5/6 times 2/3. Now here you would do the multiplication first. But usually when we do the multiplication, before we actually multiply, we try to simplify as much as possible to keep the numbers in check. And so with that, I'll have 13/6 minus, here, since I canceled the 6 out and left a 3, 5 times 1 is 5. 3 times 3 is 9. Now I can't finish this off until I have a common denominator. The LCD for 6 and 9 is equal to 18. So I'll rewrite each of my fractions over 18. Starting with 13 over 6, I got to multiply 6 by 3 to make the 18. 13 times 3 is equal to 39. Similarly, 9 times 2 is 18. 5 times 2 is 10. And we end up with 29 over 18. Now, you may put your answer as a mixed number if you so desire, but the textbook and the problems did not say I had to. So unless I'm told I have to do it, I won't bother with it. So I'll leave my answer as an improper fraction when I'm allowed to. It's just easier to leave it that way. There's no reason, if you're not asked to put it as a mixed number, don't bother going through the effort to do it, because you could make a mistake in that process. And then you'd be introducing a mistake that wasn't needed. Let's move on. Next I have 7/9 minus 1/6 divided by 3/8. Once again, according to the order of operations, I have to do the division first. So I'll have 7/9 minus 1/6 times 8/3. Remember to take the reciprocal of the second fraction. And here, it looks to me like the only simplifying I can do is to factor out a 2 from both the 8 and the 6. And so I have 7/9 minus, here I have 1 times 4 minus 4/9. And that is 3/9, which simplified is 1/3. You can pretty much guarantee that you will be required to simplify your answer. So be prepared to do that. Just do it every time, and then you won't have to worry about it. Next, I have negative 10 over 27 divided by 1/6 plus 7/9. Now, I have a parenthesis now that has stuff inside of it. I have to add those things first. So I need the LCD between this 6 and this 9. We did this before. The LCD between 6 and 9 is 18. So let me go ahead and get that in play. So the 1/6 will become 3 over 18, and the 7/9 will become 14 over 18. When I add them together, I get 17 over 18. And I don't need this parenthesis anymore, because once I add them together, I've done all that I need to do in the parentheses. So I can drop it and move on to the division now. Times 18 over 17. And can I do any simplifying? The only place I can see that I can simplify is that 9 goes into 18 twice. 9 goes into 27 3 times. Don't forget the negative sign. In the numerator, it looks like I have 20. And in the denominator, it looks like I have 51. And I don't see it simplifying anymore. Well, I already did the simplifying, so I know that I can't make it any simpler than that. Next, we have 1 minus 3, parenthesis, 2/9 squared plus 5/9. And once again, that parenthesis is just there to hold the whole fraction inside of it. So I need to do the exponent. So I have 1 minus 3 times. Between the 3 and the parenthesis is automatically a multiplication. Now let's do 2/9 to the second power. 2 to the second is 4. 9 to the second is 81. Now I need to do that multiplication. That's not too bad if I think of it this way. Now I can do a little simplifying. 3 goes into 81 27 times. So I'll have a 4 over 27 there. And now to finish this off, I should get a common denominator. So I'm going to think of the 1 as 1 over 1. And between all three of these fractions, the LCD is 27. So that 1 over 1 will be 27 over 27. And 5 over 9 will become 15 over 27. Now I can go add and subtract straight across. 27 minus 4 is 23, but plus 15 is 38. And I don't see any simplifying because the only things that go into 38 are 2 and 19. And the only thing that goes into 27 is 3 and 9. So there's nothing compatible for canceling in that case. Let's try the next one. 8/5 times negative 8/9 plus 3/4. Once again, I got to do the parentheses first, so I will do the same thing as before. I'll get a common denominator inside of the parentheses. The LCD of 4 and 9 is equal to 36. That's because they have nothing in common, so you simply have to multiply the 9 and the 4 together to give you 36. So inside the parentheses, I'm going to rewrite each of the fractions so that they're over 36. The negative 8/9, let's see. That 9 I had to multiply by 4 to make it into a 36. 8 times 4 is 32. And then 4 into 36 goes 9 times. 9 times 3 is 27. Now, as I've mentioned before, it's probably a better idea to put the negative attached to the 32. That way, when you add them together, you're going to do negative 32 plus 27, and you'll end up with the following. Negative 5 over 36. And I've dropped the parentheses because I don't need them anymore, and it will allow me to move on to the next step, which is the multiplication. Before I do this multiplication, there's a lot of canceling that can go on. For example, the 5s can be completely gone. I can even cancel some stuff between the 8 and the 36. 4 goes into both of those numbers. Don't forget it's a negative. Positive times a negative. And then in the numerator, all I have is a 2, and then in the denominator, all I have is a 9. Next, I have 5/4 to the third power minus negative 5/8 squared. I'm going to do the exponents first for obvious reasons, so I'll bring down my minus sign. Now, 5 to the third is 125. 4 to the third is 64. Now, when I take a negative number and I square it, those negatives cancel, so they're gone. All I have to worry about is 5 to the second, that's 25. 8 to the second is 64. Well, that is a matter of luck that they both have the same denominator. Now I can simply do 125 minus 25 is 100, like so. And this can be simplified quite a bit. A 4, if I divide 4 into 100, I get 25. If I divide 4 into 64, I get 16. And that's as far as I'll be able to go with that one. Now this one here, I have to work the parentheses first. The LCD between 3 and 4 is equal to 12. So I'm going to change this to negative blank over 12 minus blank over 12. So until I get finished with the parentheses, I'm not going to square it. Let's see here. 3 times 4 is 12. 2 times 4 is 8. 4 times 3 is 12. 1 times 3 is 3. So now if I do negative 8 minus 3, that's negative 11. If I take a negative times a negative, which is what I'm doing here, the negatives cancel. And I just take 11 to the second power and 12 to the second power. 11 squared is 121. 12 squared is 144. Next, I have 3 and 3/5 minus 8 divided by 5 and 1/3. I guess before you do any kind of PEMDAS, I would make all of my mixed numbers into fractions. So let me do that before I do any other steps. So when I do 3 and 3/5, remember you do 3 times 5 is 15, plus that 3 makes it 18 over 5. You might as well make the 8 as 8 over 1 because you're going to be dealing with fractions anyways. And the 5 and 1/3, 5 times 3 is 15 plus 1 more is 16. So I get 16 over 3. Now according to PEMDAS, I have to handle the division first. So I'll take the reciprocal of the second fraction. Notice that I can cancel an 8 into the 16. So I have 18 over 5 minus 3 over 2. The least common denominator between 5 and 2 is 10. So I'll rewrite it so everything is over 10. Starting with the 18 over 5, 5 times 2 is 10. 18 times 2 is 36. 2 times 5 is 10. 3 times 5 is 15. 36 minus 15 is 21. And there we go. Let me see if I can come up with a really brutal one to finish this off. Here we're going to have negative 1/3 plus 2 over 15, all of that divided by 3/5 times negative 2/3 to the third power. Now, as I scan through this, these parentheses have things to do inside of them. These parentheses are just holding the negative 2/3 inside of it, so it's not, I don't need to do it first. This is only an exponent, and I handle that after the parentheses. So this is the thing that I want to handle first. So once again, I'm going to look inside of here. The LCD there is 15. So in that parenthesis, let me change everything to being over 15. The 2 was already handled. And oh, I'll attach the negative to the numerator when I'm done. 3 times 5 is 15. Then 1 times 5 is 5. So I'll put a negative there. Got it? Now let me go ahead and add those fractions inside of there. Negative 5 plus 2 is negative 3. And notice that I've dropped the parentheses because I finished that part off. Before I do anything else, I am going to simplify. I notice that 3 goes into 15. 3 goes into 3 one time. 3 goes into 15 5 times. So we have negative 3/5 divided by 3/5 times negative 2/3 to the third power. I think I made a mistake here. Right here. That's a 1/5. My bad. Now what's next according to the order of operations? The exponent. If I take negative 2/3 times itself 3 times, I will have a negative number. So no matter what, I'm still going to have a negative. But now I take 2 to the third power, and that's 8. 3 to the third power is 27. Now, pay attention here. I have a negative divided by a positive, which will make a negative. All this stuff is negative. Then if I multiply it by a negative, the whole thing becomes positive. So I can completely ignore the negatives in this problem. The negatives all cancel out. So let me go ahead and rewrite this as 1/5 divided by 3/5 times 8 over 27. Now don't think that you have to do the multiplication first. Remember, when it comes to PEMDAS, you do whichever comes first between multiplication and division. The fact that division comes first means that I'll do division first. So let me handle this part first and leave the 8 over 27 till I'm done with that. So I'll put my 8 over 27 here with the dot, waiting for whatever happens up here. That part is 1/5 times 5/3. So I can cancel the 5s there. And for this, I'll get 1 over 3. And then we're ready to finish it off. 1 times 8 is 8. 3 times 27 is 81. And there you go. So I hope I did enough examples of problems like that. Certainly the homework, you'll have millions of homework problems dealing with these order of operations. And you'll find out that at the end of every section, like when we teach you something new, like fractions, order of operations, the next thing will be decimals. And then we'll do at the end of the decimal section, order of operations. And then after that, percentages. So you'll get the idea. They all follow a certain pattern, but we always try to end it off with the order of operations and solving equations. And that's what 3.8 is. We're going to solve equations containing fractions Let's take a look at an example. All right, to solve a problem like this, to get k by itself, you would subtract 3/8 from both sides. So you would, in fact, get k by itself, but what does the other side equal? Well, here you have to do 19 over 32 minus 3 over 8. Well, the LCD between those two is 32, so I have to rewrite them both over 32. Well, the 19 over 32, I didn't have to do anything there. But the 3/8, I had to multiply the 8 by 4. 4 times 3 is 12. So 19 minus 12 is 7 over 32. So there was a couple of steps. It wasn't that bad. Let me show you an alternative. As an alternative, let's redo the same problem, k plus 3/8. Let me fix that 8. That doesn't even look like an 8. And that was what, 19 over 32? I'm going to try to avoid fractions as much as possible this time. Notice that the LCD equals 32, which is the same as it was before. So I haven't had to do anything more. But what I'm going to do is multiply both sides, or multiply the whole equation by 32. So if you remember your distributive property, that means I've got to multiply 32 times each and every one of those things. So I will get a 32k plus 32 times 3/8 equals 32 times 19 over 32. Now, you might want to make all these 32s over 1 so that the multiplications make sense. 32k is no big deal. I'll just bring that down. However, notice that 8 goes into 32 4 times. And so this part right here is just 12 over 1, or 12. Similarly, look at the other side. These 32s wipe away completely, and you're left with just 19. So look, no fractions. If you multiply the whole equation by the LCD, you're guaranteed to wipe out all the fractions. And you may find this a little easier to do than the previous problem. I realize the previous problem was easy, but they will get harder, as you probably know. Now to solve this, we've done this 100 times now. I simply subtract 12. And 32k equals 7. And then I'll divide both sides by 32. And so we'll get k equals 7 over 32, which is the same answer that I got before. So I am an advocate for this, clearing out the fractions and then working it. Although there's more than one way to do every type of an equation. If you want to stick with the fractions throughout the equation, you can. I recommend getting rid of them. Let me show you why. As things get more complicated, you'll see why it's a desirable way to do it. So what I have here, let's start with 11 over 18 equals x plus 5/6. Now once again, I realize this is a simple problem. I know that I can write 5/6 as 15 over 18 and do an easy subtraction. But nonetheless, let me find the LCD is equal to 18, because 6 does go into 18. So I will multiply the whole thing by 18. So remember to distribute to all 3 parts of the equation. I'll have 18 over 1 times 11 over 18. I'll have 18x. Then I'll have 18 over 1 times 5/6. Now this is where I clear out all my fractions. These 18s can go, leaving just 11. Between the 18 and the 6, 6 goes into 18 3 times. Now, solve it like you normally do. I will subtract 15. I would -4 equals 18x. And to finish it off, I will divide by 18. And I get -2/9 equals x. The 4 goes into it. There's a 2 that goes into both the 4 and the 18. So I simplified my final answer. So that's the gist of this. And you'll see the problems will get harder. So you'll see my technique of multiplying by the LCD will be useful as the problems get worse. Let's try again. -7 over 15 equals -1/2 plus y. Here, the LCD equals 30. So I'll multiply 30 times everything. And so I'll have 30 over 1 times -7 over 15 equals 30 over 1 times -1/2 plus 30y. And now let me clean up. Between the 30 and the 15, 15 goes into 30 twice. So for this piece right here, 2 times -7 is -14. Between the 30 and the 2, I can cancel. 15 times -1 is -15 plus 30y. And then once again, normal procedure to solve the problem. So add 15 and then divide by 30. Now, sometimes it depends on how simple the problem is. Like this, I doubt I would multiply everything by 7 here, to be honest, because it's so easy to get c by itself by adding 4 that you may save some time by not even bothering with it. And then noticing that the LCD is 7, you'll see that you get 22 over 7. So you could multiply everything by 7 and get the same answer, but I'm not sure it will save you much time, if in any. So I think when they're really simple like this, just go ahead and roll with it. If you see something like this, it's really simple. Since you divided by 3, multiply both sides by 3. On the one side, I'll make it 3 over 1, but on the other side, I'll just call it 3. That way those cancel, and I'm left with a equals 36. Next, I have 12 equals -k over 8. So to get k by itself this time, I will multiply both sides by -8. That way I wipe out the negative and the 8 at the same time. Negative, 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 those all go away, leaving just a k. And then 8 times 12 is 96. Similarly, if I have 1/6 t equals 7. In order to get rid of that 1/6, I can simply multiply by 6 over 1. Or 6, whatever you want to call it. So I get 42, t is equal to 42 when all is said and done. Next I have negative 3/8 equals negative 1/10 b. So I got to wipe out that 10 that's attached to the b or underneath of the b. And I can take out the negative all in one step simply by multiplying this whole thing by negative 10 over 1. And do the same thing on the other side. That way the negative 10s cancel, and I'll be just left with b. On the other side, though, notice that 8 and 10 do share 2 as a common factor. 2 goes into 8 4 times, 2 goes into 10 5 times, and negative times a negative is positive. So it looks like I'm left with just positive 15 over 4. Next, we have 42 equals 6/7 c. So now, for a lot of people, they go, well, divide by 6/7. Well, remember, if you divide by 6/7, that's the same as multiplying by 7 over 6. So I prefer to do this. Multiply both sides by 7 over 6. That way, the fractions will cancel out and you'll be left with just a c. The other side I can handle if I put the 42 over 1. 6 goes into 42 7 times. So now all I'm left with is 7 times 7 over 1. That's 49 over 1, which is just 49. Let's see what we have next. Negative 13 over 9n equals 5 over 12. So remember, you're trying to wipe out the stuff that is attached to n. So I'm going to multiply the left side by negative 9 over 13. That way I can wipe out all the numbers that are attached to n, but don't forget to do it to the other side. So the 13s cancel, the negatives cancel, the 9s cancel. You're left just with n. And then on the right side, I can't do anything about the 5 or the 13, but notice that 3 goes into both 9 and 12. 3 goes into 9 3 times, 3 goes into 12 4 times. Additionally, I have a positive times a negative will be negative. Now let's see what we get for the numbers. 5 times 3 is 15. 4 times 13 is 52. Next, we have 6z equals 2/7. So this is one where you look at the 6 and you go, man, I could just divide both sides by 6, but that will make the other side unusual. So what I prefer to do instead in these situations is to multiply by 1/6. And that way it makes the multiplication on the other side fairly simple. Notice between the 6 and the 2 I can do some canceling. And I end up with 1 over 21. These 6's cancel is equal to z. Next we have negative 9/10 equals negative 2r. So to clear out the negative 2, what I'm going to do is multiply by negative 1/2. And I'll put that 2 over 1. That way these all cancel out completely. So on the right, you're left with just r. On the left, Notice that the negatives cancel, but that's it. It looks like I'll just have 9 over 20. Next we have 15f plus 8 equals 13. And this is a problem that you've been doing for a while now. Subtract 8. And then I can divide by 15. The 5 goes into 15 3 times, so I'm left with just f equals 1/3. So in a situation like this, I doubt I would multiply everything by 3 right off the bat. I think what I would do, since it's so simple, subtract 11 first, like so, and then I can multiply both sides by 3. And I'll be left with just b equals negative 21. These 3's, of course, canceled out. Next, I have 12/7 a minus 3 equals 5. I'll do the same thing as before. I'm going to add 3, add 3. Okay, 12/7 a equals 8. So to get the a by itself, I'm going to multiply both sides by 7 over 12. Make the 8 over 1 so it's easy to do the multiplication. These, of course, will cancel out, and I'll be left with just a on the left. On the right, notice that 4 goes into 8 and 4 goes into 12. So on the right, I'll get 14 over 3. Next, I have 10 equals negative 9/4 c plus 8. Let me subtract 8. Subtract 8. So I'll get 2 equals negative 9/4 c. Now to get c by itself, I want to multiply by 4/9. Not just 4/9, negative 4/9. So I'll cancel the fractions and the negative at the same time. Just make the other side 2 over 1. On the left, it looks like I get negative 8 over 9. On the right, all the numbers cancel. I'm left with just c. Next is a somewhat complicated equation, sorry. And that's an h. Now in this problem, I do recommend multiplying everything by the LCD because there's a lot of fractions. There would be a lot of calculating of LCDs as you go along. We could probably make it easier by just taking care of the LCD right at the beginning and then wiping out the fractions. So if you look here, look at the denominators. We have a 5, a 2, and a 3. They're all prime numbers, so the product of them is the LCD. So 5 times 2 times 3 is actually equal to 30. So I'm going to multiply everything by 30. That means you've got to distribute the 30 to each and every part. So I will have 30 over 1 times 2/5, 30 over 1 times 1/2, minus 30 over 1 times 2/3 h. And let me simplify all these things. Remember, the goal of doing this is to wipe out all the fractions right off the bat. Notice that 5 goes into 36 times. So all that's left of this piece on the left is 12. Similarly, 2 goes into 30 15 times. And 3 goes into 30 10 times. And now it's just like any of the other problems we did. I'll subtract 15. I will get negative 3 equals negative 20h. Then to finish this off, I will divide by negative 20 on both sides. And I will get h equals 3 over 20. So most of the rest of these problems that I'm going to do are going to require, or at least the way I'm going to do them, is to multiply by an LCD, because these are going to get pretty bad. The last 4 examples are going to be kind of heavy. So let's see what we have then. So on this example, I'm going to get negative 9/10 equals 3/10 C minus 3/4. I would like to clear the fractions. Well, the LCD, if you look between 10 and 4, they both go into 20. The LCD is in fact 20. So I'm going to multiply everything by 20. I don't know if this helps you to visualize it, but I put this little rainbow kind of things to remind you to distribute the 20. So when you distribute the 20, sometimes it's beneficial to have it over 1. And now I'm ready to simplify. Between the 20 and the 10, I can cancel. So 2 times negative 9 is negative 18. Between the 20 and the 10, same deal as before. I'll get 6C. And then finally, 4 goes into 25 times. I get minus 15. I'll add 15 to both sides. And I'll get negative 3 equals 6C. I'll divide by 6. And I will get negative 1/2 is equal to C. Next we have 1/5 B plus 1/3 B equals 8. Well, the LCD here is 15. So I multiply everything by 15. So 15 over 1 times 1/5 B plus 15 over 1 times 1/3 B equals 15 times 8. Between the 5 and the 15, I can cancel and get a 3B for that part. On the other one, 3 goes into 15 5 times. I'll get a 5B. 8 times 15 is 120. Notice how simple it is once the fractions are all gone. I can divide both sides by 8, and I'll get B is equal to 15. Next, I have 10Z over 7 minus 3 equals 3Z over 2. Here, the LCD between 2 and 7 is 14. So let's multiply everything by that. So I get 14 over 1 times 10Z over 7 minus 14 times 3 equals 14 over 1 times 3z over 2. Now remember, this is going to clear all the fractions out. 7 goes into 14 twice. That leaves me with a 20z in that spot. 14 times 3 is 42. 2 goes into 14 7 times. That leaves me with a 21z off to the right. I think it's easier to subtract 20z here. And it's nice because you'll just be left with z on the right, and on the left you'll get negative 42. Next we have 4w over 9 plus 1/3 equals 4w over 3 minus 7/9. Here, the LCD is simple. It's just 9. Notice that all those denominators do go into 9. But you'll have to multiply it to 4 different pieces. So I get 9 over 1 times 4w over 9 plus 9 over 1 times 1/3. 4 over 9 times 4w over 3. I don't know why I did that. That is a 9 over 1. And finally, minus 9 over 1 times 7 over 9. So I can cancel the 9's and get a 4w for the first part. 3 goes into 9, 3, so I get 4w plus 3 on the left. On the right, 3 goes into 9 3 times, so I get 12w. And finally, those 9's cancel, minus 7. I always try to get the letter by itself on one side. So I am going to, I guess, subtract 4w. That gives me 8w minus 7 on the right and a 3 on the left. So I will add 7, add 7. So I get 10 equals 8w. I will divide both sides by 8. And notice that 2 goes into both 4 and 10. All right, and to finish out this section, we have a couple of a few word problem type things. But first, what I want to do is start with a simpler, not a full word problem, but something you've seen before. I want you to write an equation and solve it. So let's see what type of an equation. Well, let me see what I'm going to do is write down a sentence, and from that sentence I want you to make an equation out of it. So here's what it says. 5 more than half a number is 13. So remember, when you're doing these things, I think it's easiest to put your equals where the is located. That way you know which side is the left and which side is the right. Numbers themselves are easy. So 13 comes down as 13. 5 comes down as 5. The more than part is addition. And then half a number, I'll call it 1/2 x. So there's my equation to solve. And then to figure out what it is, I will subtract 5 from both sides. I will get 1/2 x equals 8. And then I'll multiply both sides by 2. So if you will, there's two parts to the problem. There's writing the equation, so there's the equation, I'm circling it, and then the answer to the equation. Let's try another one of those. 2/3 of a number is -34. So let me transcribe that. The is an equals, -34 is equal. I mean, it's simple. Then 2/3 of a number looks like 2/3 x. So there's one answer. Now I need to solve it. To solve this, I'll multiply both sides by 3/2. And I'll put the 34 over 1, so we'll make life a little easier there. The left will get an x. Notice the 2 goes into 34 17 times. So you're left with x is equal to -51. For my last couple of examples, I wanted to take a couple of problems out of the textbook. So these come from section 3.8 in your textbook. Problem number 98 is one of the ones that I want to do. And let's go ahead and take a look at it. In Jessica's history class, the number of students who bought an e-book was half the number who bought a hard copy book. We've got 39 students. How many bought each type? So what I can do, I can write the answer and say blank students bought the e-book and blank students bought the hard copy. Now remember, you want to label these blanks one way. So I want to use some sort of an unknown, like a letter X or something, in one of these blanks and use other information to fill in the other blank. So let's take a look at what can give me clues here. The number of students who bought an e-book was half the number who bought a hard copy book. So that means if I call this one X, this one is 1/2 X. Alternatively, if you would have called this one X, then this over here would have been 2X. But I'm using the words that were in here. So we know that the number of people that bought an ebook plus the number of people that bought a hard copy total up to be 39. Now to do this, this may or may not be difficult for you, but I don't know how I want to do it. I am just going to add the x's together, and you take a moment to see if you can get the 3/2 like I do. It's basically 1/2. To solve this then, I will multiply both sides by 2/3. That way that everything cancels on the left. On the right, 3 goes into 39 13 times, and I get x equals 26. The beauty of this now is that I know that in this blank goes a 26, and in this blank, half of 26 is 13. So there you go. Another example from the textbook, I am going to grab problem 100. All right, we have a 28-foot long cable must be cut into 2 pieces. One piece is 3/4 as long as the other. Find the length of each piece. So we can just say one piece is, what are these feet? Okay, is blank feet long, and the other is blank feet long. So let's see here. It says one piece is 3/4 as long as the other. So I guess if one piece is x, then the other is 3/4 x. That way one piece is 3/4 as long as the other. I'm told that if you add them up, they add up to 28 feet. So I get x plus 3/4 x equals 28. Once again, this is 1 3/4. To me, this is just 7/4 x equals 28. And then to finish this off, I will multiply by 4/7. Like so. I'll get x on the left. On the right, 7 goes into 28 4 times. So I get x equals 16. So I can put 16 in that blank. And then I've got to do 3/4 for the next one. So let me get 3/4 times 16. That's going to be a 12 into that spot. Notice that 16 plus 12 does equal 28.